Welcome to my channel. I'm Zhang Xu. Let's look at the problem 40 in chapter 27. Chapter 27 is about magnetisms. So there we look at this question. Tell us we have a non-conducting object. So first the keyword non-conducting. Tell us the charge is uniformly distributed, right? And the length d. So length is total is d. Carries uniformly distributed charge q. So let's see it again. The charge is it rotates in angular velocity omega, so it rotates with omega about an axis perpendicular to the object at one end. So this one is the end. So this one just do circular motion on this plane, right? Ask you, show that the magnetic dipole momentum of this rod of this object equal to this one. It was a little bit difficult, but the most important thing is a hint. Normally the hint gives you the answer. So we look at the hint together, tell you, consider the motion of each infinitesimal length of rod. So keyword, infinitesimal. That means we can cut this object in infinitesimal, right? We cut it by small fractions, right? By infinitesimal fractions. And for each one, we call it dy, right? This is the hint to tell us. And then we do integral for this one. So now things become easy. We just consider this a small fraction, dy, right? Then we need to find its magnetic dipole moment. So normally we know the magnetic dipole momentum mu equal to n times I times a. But for this small fraction, we can consider the n just equal to 1, right? Just one circle. So look like we need to find I and a, right? Agree? Yes. Now we come to there, we can say the small fraction for this dy is du equal to a times di, because the current is a small fraction, and the a is easy, just a pi y squared. We can think it do the circular motion this way, so y becomes the radius, right? So looks like we must know the di. So di you can say is the charge on this small fraction dq over t. Agree? dq over t. Because when the travels in a circle, the charge dq, the time taken is t. T is the period, right? So next step, how can you find the charge on this small fraction? You can say the total charge on this object is q, the total length is d, and this length is dy. So of course the density for the charge is q over d, and then the length for this small fraction dy. So you can write it there, right? Next step, how can you find the t period? So you can say that for one circle, the angle moved is 2 pi, right? 2 pi, but the angular velocity is omega. So 2 pi over omega is the time taken for one complete cycle. So t equal to 2 pi over omega, right? Now we input a and di inside. It looks like this one. And reorganize it. It looks like this one, right? So we write it there. Now we can do integral for the y from 0 to d. So integral from 0 to d, you get the final answer there. Thank you.